Fantastic. Thank you very much, Helene. Welcome. Focus today will be on derivatives. And in particular, what we're going to be looking at is forward rate agreements and swaps, largely because most people don't have much of a clue about forward rate agreements and swaps. The examiner knows that and therefore tests them relatively heavily. So we're going to go through all the computations and calculations and try and get a good understanding. So we'll look at the FRA first, then we'll go into interest rate swap, currency swap, and equity swap. Interest rate swap, yeah, it's not too bad. Currency swap is certainly the hardest, and equity swap is actually the easiest of the three swaps we have to look at. Trouble is, it comes last in the materials, and most people have given up by then. So we're going to try and go through all of those. Hopefully, you've got the slides for this presentation. We're going to cover some slides, and then we're going to cover a couple of item set-based questions. You should have got a link today that allows you to download the PDF that includes the slides and the questions. If you haven't got it, don't worry, you'll be able to follow everything on the screen. And as Helene said, this will be archived afterwards. We're scheduled to run for 2 hours, so up till 6 o'clock your time, 5 p.m. my time. Chances are, having a look at the amount of material I put in this, I think it might go slightly over that 2 hour time limit. So if it does and you need to drop, don't worry about that. It is all going to be recorded and archived so you can pick up on anything that you've missed at a later date. And as Helene said, if you could enter any queries you have in the chat box, I'll come to them at the end of the presentation, simply because I can't look at the chat box and give the presentation at the same time. I can't multitask. There's my email address as well on the front of this, jonathan.bone@kaplan.co.uk. Any queries, please feel free that you can email me on that as well. Obviously, I work for Kaplan Swayze, and as Helene said, I'm a seasoned lecturer, I think she called me. I think that possibly is another name for old. So I've been around for a while. I qualified, gained my CFA charter about 15 years ago now, probably longer than that, to give you a bit of my background. And before that, I worked in corporate finance, but now I'm head of product for Kaplan Swayze, so I get the joy of writing the books and editing the books and materials that you see if any of you are using Swayze. Fantastic. Right, let's jump into it then. Let's get straight into our slides. As I said, we're going to focus on two things predominantly here: forward rate agreements and swaps. So a forward rate agreement, we're often going to see these simply referred to as FRAs. Okay, now it says a FRA is an agreement to borrow long or lend short in the future. Typically, and we can see this actually a couple of slides later, I'll just jump a couple of slides later, a long FRA is an agreement to pay fixed and receive floating from the expiry date of the FRA to the end of a notional borrowing and lending period. So long FRA, I'm always thinking pay fixed, receive floating. Short FRA, it's going to be the other way around, pay floating and receive fixed. And of course, it is a forward contract, so one party by definition is long and the other party is short. Okay, let's jump back. Okay, so the forward price in a FRA is the fixed rate. So today at T0, when you take out your FRA or you enter the contract, we know what the fixed rate is. What we don't know is what the floating rate will be. We're only going to discover the floating rate at expiry of the forward rate agreement. Again, as you can see, it's usually based on LIBOR. It certainly will be based on LIBOR interest rates. And we're going to look at that as 30 days in a month, 360 days in a year. That is our day count convention for the exam. So essentially 30 days in a month, in case you were wondering. In reality, LIBOR, of course, has different day count conventions depending on the currency you're looking at. So if you're looking at dollar LIBOR, it's 365, sterling LIBOR 360, etc. In our exam, every single currency will use a 360 day count convention, so you don't need to worry about the real world here. Okay, now we've got an example of a 2 times 3 FRA here. Now you see two dates. The first date is in months, so this is at the expiry of the FRA. Okay, and that's in 2 months' time or 60 days. And the other date you see is the end of borrowing and lending. Okay, so what this is saying is we've got a FRA that expires in 2 months' time, and at that point you enter the borrowing and lending agreement, and then the end of the borrowing and lending agreement is in 3 months' time, or if you like, 90 days. So what we've actually got is borrowing and lending for 30 days, starting in 60 days' time. Okay. So as we said, the loan can be viewed as borrowing at a fixed rate and lending at a floating rate, starting here at the expiry of the FRA in 2 months' time, and for a term that ends 3 months from today, so i.e. day 90. So we've got borrowing and lending, 30-day borrowing and lending, commencing in 60 days' time. Okay, so again, if you want that a little bit more visually, today the fixed rate is established. We actually know what the fixed rate is, and we're going to see that the fixed rate in a FRA is nothing more than a forward interest rate. And of course, you saw those computations, in fact, more complicated computations in fixed income at level 1, where you had to calculate forward rates from spot rates. And of course, you've got that in level 2 fixed income as well, calculating forward rates from spot rates. Here, we're going to be calculating forward rates from LIBOR rather than spot rates. And in fact, that is a little bit simpler because LIBOR is a simple interest rate rather than being an effective interest rate. So there's no compounding essentially involved. So today at T0, we established the fixed rate, and we'll talk about exactly how that's established in a minute. Then, of course, the first date we have is expiry of the FRA. So that happens in 60 days. We then discover in 60 days what 30-day LIBOR will be. So it's at the expiry of the FRA that we discover what LIBOR will be. Then we've got a borrowing and lending period from day 60 to day 90. So in this situation, if we're long the FRA, we are going to be paying fixed interest from day 60 to 90 and receiving floating interest. Okay. But as I said, that floating rate is discovered only at the expiry of the FRA. We do not know it when we enter the forward rate agreement. That's the big, essentially, unknown when you enter a forward rate agreement. So as we said, we've got 30-day borrowing and lending commencing in 60 days' time, between day 60 and day 90. As I mentioned, long FRA, pay fixed, receive floating. Short FRA, pay floating, receive fixed, always from expiry of FRA to the end of the borrowing and lending period. Right, okay, so what are FRAs actually used for? Now, CFA Institute is rather silent on what FRAs are used for, and in practice, they're one of the most commonly used interest rate derivatives in the marketplace. So they're extensively used, especially by corporates for hedging short-term borrowing. Now, you can use them to speculate on interest rates. Now, a long FRA gains when interest rates rise, because in a long FRA, you are paying fixed and receiving floating. When interest rates rise, the basic idea is fixed rates essentially are increasing. The fixed rate in a new FRA would be higher than the FRA that you've entered into, and therefore you're paying fixed interest at a lower rate. Okay, and therefore the long FRA will gain when interest rates rise. Now, conversely, the short FRA has got to be the other way around. Here you're receiving fixed interest. Okay, so if interest rates go up and the fixed rates in FRAs start to rise, then the interest you're receiving is essentially lower than if you'd waited and entered a FRA at a later date. So short FRAs will tend to lose when interest rates rise, but gain when interest rates fall. So yes, you can use them for speculation, and just take into the exam, long FRA is going to be useful to speculate when interest rates are rising. Short FRA is going to win when interest rates are expected to fall. Now, that's true, you can use them to speculate on interest rates, but the vast majority of FRAs are used to hedge future borrowing. So in other words, locking into a fixed interest rate for future variable borrowing. And the idea is we're going to enter a loan, or we're going to have to take out a loan in the future, and that loan is going to be LIBOR based. And of course, when you go to a bank, a retail bank or a wholesale bank, typically when they're offering corporates loans, those are floating rate loans. They pay, essentially the borrower pays LIBOR. Okay, it's very unusual to have fixed interest unless you're issuing bonds. Okay, so we're typically talking about corporates here that are borrowing floating interest rates. Now, of course, if you're going to take out a loan in the future and you know the interest rate is going to be a variable rate linked to LIBOR, your big risk is by the time you come to take out your loan, LIBOR might have risen and you'll end up paying higher financing costs on your loan. So what a FRA is going to do is it's going to provide a corporate, a company, a way of locking into a guaranteed interest rate for future borrowing. Let's see how this works. So we've got a company here, company A, and they're going to borrow 10 million for 6 months, starting in 3 months' time. So in other words, essentially, we're going to find that this company is going to start borrowing in 3 months' time, and they're going to borrow for 180 days. Okay, so they're going to borrow for 6 months, and the end of the borrowing and lending period will be in 9 months' time. Now, because they're taking out a 6-month loan in 3 months' time, their big risk is LIBOR increases in that time. Notice Company A's bank is willing to lend to Company A at LIBOR plus 60 basis points. Okay, so of course, what that means is if LIBOR starts to rise over that 3-month period, they're going to pay more on their 6-month loan. They want to eliminate their interest rate exposure, their exposure to interest rates changing. So let's have a look at this. So Company A is going to enter a 6-month floating loan starting in 3 months' time, and the interest rate they'll be paying on that loan will be 180-day LIBOR in 3 months' time, plus 60 basis points, okay, plus the spread. So as I said, the big risk, therefore, is what's going to happen to 180-day LIBOR in 3 months' time. It could be higher than current 180-day LIBOR. So there's uncertainty for the company. So they want to remove that uncertainty. So what they're going to do is take out a long FRA position. So they're going to go long a 3 times 9 FRA. 3 times 9, remember the expiry date is in 3 months. 3 times 30, so in 90 days, okay? And the end of the borrowing and lending is in 9 months' time, which of course is 270 days. And the time between there is 180 days. So they're borrowing for 180 days, commencing in 90 days' time. Now, the price they've been quoted today at T0 is a rate of 5%. So the forward price in this FRA is 5%. Now, remember, the forward price in a FRA is the fixed rate in the FRA. Okay, so if they go long FRA, remember they're paying at 5% and receiving LIBOR. So they're paying fixed at 5% and receiving LIBOR. Now, significance is once they've entered this agreement, they now know exactly what their borrowing costs will be. Their borrowing costs will be the fixed rate in the FRA plus the 60 basis points. In other words, they'll be paying 5.6% on their borrowing starting in 3 months' time and lasting for 180 days. Let's just prove that for a second. So let's imagine 3 months has passed. So 3 months have now passed. So we're at the point where the company needs to take out its loan, and we're at the point where the FRA essentially expires. Let's imagine that LIBOR at this point is 6%. Okay, so when they take out their loan, they're going to be paying 6% plus the 60 basis points. So they're going to be paying 6% plus 60 basis points. Okay, remember 100 basis points is 1%. So that's what they're paying on their loan. But think about now the FRA. The FRA is pay fixed, receive floating. So they're going to receive 6% on their FRA. They're going to be paying 5% on their FRA, and that gives them a net receipt of 1% on the FRA. So in comes 1% on the FRA. So now look at their scenario. They're paying 6.6% on their loan. They're receiving 1.1% on the FRA. And of course, 6.6 minus 1 gives us our 5.6%, which is exactly what we said it would be. So notice by taking out the FRA, essentially what they've done is they've removed their exposure to floating interest rates and replaced it with an exposure to a fixed rate. Now that's great if LIBOR goes up, but of course not so great if LIBOR goes down. So let's have a look at a scenario now. Again, 3 months have passed, so we're at the expiry of the FRA, but this time LIBOR turns out to be 4%. Now, of course, on their loan, they're now paying 4% plus 60 basis points. On the FRA, they are paying fixed, receiving floating, so they're receiving 4%, the 180-day LIBOR. They're paying the fixed rate of 5%, and of course that gives them minus 1%. Or if you like, they're paying out 1%, a net 1% on their FRA. So again, look at their total borrowing costs. 4.6% on the loan, plus a further 1% on the FRA. Add those two together, and again, you've got your 5.6%. So 4.6 plus 1 equals 5.6. Exactly what we said before we'd done any numbers at all. So the key point and the key use of FRAs is, for a company's point of view, they can lock into a fixed rate of interest for future borrowing. Okay, completely remove uncertainty caused by interest rate volatility. And of course, that works in both ways. In this situation, great if interest rates have risen, not so great if interest rates have fallen. But what they do have, of course, is absolute certainty. They now know they're going to be paying 5.6%. Now, again, is that knowledge really a requirement of the CFA syllabus? Not really. It talks about FRAs being used to hedge short-term borrowing. It never really gives you much examples of it. But I think it's worth seeing, because once you see this, then you understand what these FRAs are actually being used for, and therefore why they're so popular in practice. So not only can we speculate using FRAs, but we can also hedge short-term borrowings, locking into guaranteed fixed rates. Okay, so let's get into pricing. The pricing, of course, is the forward rate. Okay. And the forward rate in a FRA is our fixed rate. So notice it says the price of a FRA, the fixed rate, is an implied forward rate. Okay. In other words, it's the forward rate from the FRA expiry to the end of the borrowing and lending period. So essentially, in our example of a 2 times 3 FRA, our forward rate would be a 30-day forward rate commencing in 60 days' time, because the FRA expired at day 60. The end of the borrowing and lending was day 90. So we had 30-day borrowing and lending starting in 60 days' time. So the FRA price will be a 30-day forward rate commencing in 60 days' time. And in order to calculate that, what we're going to need to have is 60-day LIBOR today and 90-day LIBOR today, and then we can compute the forward rate. And as I said, this forward rate really is exactly the same as the forward rates that we've calculated in fixed income at level 1 and level 2. As I said, one thing that makes it more simple is FRAs use LIBOR, and LIBOR is a simple interest rate. It is not an effective interest rate. Okay, so it doesn't factor in interest earned on interest. So we don't need any compounding, etc. in this. Okay, so what we're going to do is try and look at a 1 times 3 FRA. So again, this FRA expires in 30 days' time, and the borrowing and lending ends in 90 days' time. So essentially, in this situation, we've got a 60-day borrowing and lending period commencing in 30 days' time. Now, the examiner will often give you 30, 60, and 90-day LIBOR. 2 of them we need, 1 of them we don't. We're going to need 30-day LIBOR. We're going to need 90-day LIBOR, but we do not need 60-day LIBOR. The 60-day LIBOR rate would be the rate from T0, i.e. today, up until day 60. What we're trying to calculate is a 60-day forward rate, okay? Not what LIBOR currently is. So the 60-day rate in this situation is erroneous. You don't need it. Right, first step, 3 simple steps to pricing a FRA. First of all, LIBOR, just like any other interest rate you ever see in the universe, apart from holding period yield, is an annualized rate. So first of all, we need to de-annualize it. So what we need to do is actually quote it over a 30-day period rather than a 360-day period. So we're going to take the 30-day interest rate of 2.4%, And simply to unannualize, because it's a simple interest rate, all we have to do is multiply by 30, number of days in the interest rate period, over 360 number of days in a year, and that gives us 0.002, or if you like, in this case, what have we got? 20 basis points. And we do exactly the same for 90-day LIBOR. So our 90-day LIBOR in our example was 3%. We're going to unannualize that by multiplying by 90 over 360. Okay. And that gives us 0.0075. So step one, deannualize your interest rates. Okay. Step two, what we're going to do is work out the forward rate by doing 1 plus the long period rate. Long period would be 90 days in this case, divided by 1 plus the short period interest rate, 30 days, and subtract 1. That will give us, in this case, a 60-day forward rate. Again, prices of FRAs are always quoted as annualized rates, so the last step is to annualize it. So let's actually have a look at how this works. So we're going to do 1 plus the 30-day rate. So 1 plus the 30-day rate is 1.002. We've got 1 plus the 90-day rate, 1.0075, and we're going to use this to calculate 1 plus our 60-day forward rate commencing in 30 days' time. So it's always 1 plus the long period divided by 1 plus the short period. So 1.0075 divided by 1.0020. We then subtract 1. That's just the 1 that we added to our interest rate, so we're subtracting that. That will give us a 60-day, because notice this period here is 60 days. That would give us a 60-day forward rate. Okay, but again, interest rates are always quoted annually, so our last step is to annualize. Because we're looking at borrowing and lending over a 60-day period, we then multiply by 360 divided by 60, and that gives us our 60-day forward rate, which is the fixed rate in the FRA, and that is 3.3% in this particular example. Okay, so that is our fixed rate. Of course, and it is known at T0. So you know that fixed rate as soon as you enter the FRA. What you don't know is what the floating rate will be. It's only when we get to FRA expiry that we will discover at T30, we will discover what 60-day LIBOR is, okay, and that will then allow us to work out the payoffs at T90. Okay, so calculating a fixed rate, very, very simple, very, very similar to your fixed income, only a little bit easier, okay. So yeah, that is our implied forward rate. That is the FRA's price. That is the fixed rate in the forward rate agreement. Okay, what we're then going to do is look at what happens if we hold the FRA all the way through to its maturity date. So we're jumping back to our 1 times 3 FRA. So it had an expiry of 30 days and borrowing and lending of 90 days. Okay, and we had our fixed rate. Okay, so there's our fixed rate of 3.3%. What we're going to try and do is work out the profit or loss on this FRA at its maturity. And maturity is just another name for the expiry date. So notice at expiry, we now discover what 60-day, and we may as well add it in, LIBOR rates are. So 60-day LIBOR rates are 4%. And we're assuming that this FRA is based on a notional principal of $1 million. And we're asked to value the FRA at settlement. Now, of course, I can now see that I'm going to, if I'm the long party paying fixed and receiving floating, I've won on this FRA, because the floating rate that I'm receiving is 4% and the fixed rate I'm paying is 3.3%. So happy days, I should make a gain. So let's have a look at this. So there's the 3.3% that you fixed at T0. Time now passes, okay, and we're now at expiry of the FRA, okay, so T0 is now what was day 30 when you took out the FRA, and we've discovered 60-day LIBOR is 4%, okay, and we've got 60 days until the end of our borrowing and lending period. So what we're going to do first of all is work out the payoff at the end of the borrowing and lending period, and that's relatively straightforward. I'm receiving LIBOR. Okay, so what I receive minus what I pay. Okay, and remember, long FRA, pay fixed, receive floating. Short FRA, pay floating, receive fixed. I'm looking at long FRA here, so I'm receiving the floating rate of 4%. I'm paying the fixed rate of 3.3%. But be careful, because those interest rates are annualized, and actually we are only looking at 60 days borrowing and lending. So the first thing we need to do is unannualize, and that is what this is doing here. We're going to multiply by 60 over 360 simply to unannualize our interest rates. We then multiply by the notional principal, in this case $1 million, and that will give us the net benefit to the long party at the end of the borrowing and lending period. So essentially, let's have a quick go at doing this. So 0.07, which is of course is 0.04 minus 0.033, times 60 divided by 360, and then times our 1 million, and I get 1,167. Okay, so 0.007 times 60 divided by 360 times 1 million, and we get 1,166.66666 recurring. I'm not worried about cents here. I've rounded up to the nearest dollar. Now, there is then one quirk. That party, that amount, 1,167, is not paid from the loser to the winner. In other words, in this case, from the short party to the long party. It's not paid at expiring. At the end of the borrowing and lending period. Instead, it's actually going to be paid at the expiry of the FRA. So that's an issue, because this is a T60-day value. So this value is in 60 days' time. The expiry of the FRA is today at our T0 over here. So all we're going to need to do is discount back our 1,167 using 60-day LIBOR, which was 4%. Okay, so discount it back. First of all, unannualize your 60-day LIBOR. So it's 4% times 60 divided by 360. That gives us 0.006666 recurring. Okay, add 1 to that. So I've now got 1.00666 recurring. Hit your reciprocal, multiply by your future value, 1167. And that gives me the present value, which is 1,159. And in this situation, it would be paid from loser to winner. And in this case, short party to long party at the expiry of the FRA, not at the end of the borrowing and lending period. It's just a small quirk of how these things typically work. So that is valuing a FRA at maturity. But the real question that really trips up CFA level 2 candidates is valuing that FRA before maturity. So after it was initiated, but before expiry, and that's what we're going to have a look at here. So valuing a FRA prior to maturity. Now, you can see the value is determined by rate changes. In other words, these are what they're talking about is changes in the fixed rate. Okay. Now, if you're long FRA, pay fixed, receive floating, you're going to win when fixed rates go up. Whereas if you're short the FRA, you're going to win when fixed rates go down. Okay. So long wins when interest rates rise, short win when interest rates fall. Yes, it's paid in arrears because the impact of the change is not realized until the end of the loan. Okay, let's have a look at this. So again, we're going back to our original 1 times 3 FRA. We know the fixed rate, 3.3%, and we've got notional principal of 1 million. So 10 days have now passed. That means essentially now we've got 20 days to expiry of the FRA. Okay. So what we're going to try and do, therefore, is work out what the current gain or loss is in present value terms to our long party. Now, in order to do this, what we're going to do is work out the fixed rate on a new FRA that has the same expiry as our original FRA. Okay. Now, remember, our original FRA expired in 30 days and then had borrowing and lending up to 90 days. Well, if 10 days have now passed, we need a FRA that's going to expire in 20 days and has borrowing and lending, again, still a 60-day period, up until day 80. So we need 20-day LIBOR and we need 80-day LIBOR. And all we're simply going to do is work out the new fixed rate. Okay. So there's our original FRA at initiation, which was T0. We locked into that 3.3% rate. 10 days have now passed. Oop. The 10 days have now gone. Okay, which means we've now got 20 days to the expiry of the original FRA and 80 days to the end of the borrowing and lending period. So remember what we're going to do here. We are just going to work out the fixed rate at the new T0 for a FRA that expires in 20 days, i.e. at the same time as our original FRA. So we're going to need 20-day LIBOR, and then, of course, what we're doing is looking at 60-day borrowing and lending commencing in 20 days' time. Okay. So what we're going to do, therefore, is compute the fixed rate for a FRA expiring in 20 days' time with 60-day borrowing and lending, in which case we need the 20-day LIBOR rate and we need the 80-day LIBOR rate. Okay, so it's the same process, really, as before. So first of all, we're going to de-annualize our 20-day and our 80-day LIBOR. Then what we're going to do is calculate what the new fixed rate would be. And again, it's the same formula as before. 1 plus the long period interest rate divided by 1 plus the short period interest rate, and then subtract the 1 that we added. And then strictly speaking, we should annualize that, in this case, by multiplying by 360 divided by 60. What we're then going to do is compare the fixed rates. We're going to look at the new fixed rate, okay, to our original fixed rate. Now, if the new fixed rate is higher than our original fixed rate, then the long party will have won. Whereas if a new fixed rate is lower than the original fixed rate, the long party has essentially lost. Okay, the floating rates are irrelevant because remember, the two FRAs, the original FRA and this new kind of pretend FRA that we're using to value our original FRA, they both have the same expiry date, and therefore LIBOR at expiry is going to be identical on both FRAs. Okay. And then finally, we're going to discount the payoff at the end of the borrowing and lending period back to today. So step one is to unannualize our 20-day and our 80-day LIBOR. 20-day LIBOR was given as 2.5%, so simply multiply it by 20 over 360, which gives us 0.00139. And 80-day LIBOR, 3.6%. To unannualize that, multiply it by 80 over 360 to get 0.008. Right, now we've got those, we can move to step 2 and work out what the new fixed rate would be. Okay, so again, new fixed rate, remember 10 days have passed. So there's 20-day LIBOR, 1 plus 20-day LIBOR, 1.00139, and 1 plus 80-day LIBOR, 1.008. Okay, and what we're trying to work out is this new 60-day forward rate, commencing this time in 20 days' time. So it's always long period, so 1.008 divided by short period, 1.00139. Subtract the 1 that you added to your LIBOR rates and then annualize. Again, the annualizing is looking at this period here. Our borrowing and lending period is over 60 days. Okay, so therefore we've got a 60-day forward rate. So to annualize, quote that as an annual rate, we simply multiply by 360 divided by 60 to get 3.96. Now, I can tell, therefore, straight away that on my original FRA, if I was the long party, I would have won. Because on my original FRA, I was paying 3.3% and receiving LIBOR. On this new FRA, 20 days later, I'd be paying 3.96% and receiving LIBOR. Okay, so I'm better off. I'm paying 3.3% rather than 3.96%. So I'm going to win as the long party on this. Okay, so let's then work that out. So we're now going to work out the payoff at expiry. Okay, and what I do is I look at the new rate, new fixed rate, minus the original fixed rate. Doesn't have an O yet, is it? See if I can spell. I can't spell. Original, it's pretty weird sometimes writing in capital. So you look at the new fixed rate minus the original fixed rate. That's if you are looking at a long FRA. If you were looking at short FRA, because you're receiving the fixed rates, you just need to flip those around. Essentially, the short FRA is lost because they'd be receiving 3.3, whereas a new FRA would be paying 3.96. So because we're looking at the long FRA, we do new minus original. So 0.0396 minus 0.033. Okay, again, we're looking at a 60-day borrowing and lending period, whereas these rates are annualized. So first step, unannualized by multiplying by 60 over 360, then multiply by your notional principal. That tells me that by T80, the end of the borrowing and lending period, I will be $1,100 better off because I've locked into 3.3% rather than 3.96%. Now, what we then do to work out the gain or loss at T0, this is our valuation date after all. So we want the valuation here at T0, okay, the new T0, 10 days after origination, remember. So all we're going to do is we're going to have to take that 1,100 and discount it, not to expiry. Be careful on this. You're not discounting back to expiry. We're discounting back to the current point in time, which is 10 days after initiation, or if you like, 20 days before expiry. So what I'm going to need to do is simply divide that 1,100 by 80-day LIBOR. Now, again, I've got to be a bit careful, of course, because I need to unannualize 80-day LIBOR. Okay, and our unannualized 80-day LIBOR was 0.08. So if I take my 1,100, the payoff at the end of the borrowing and lending period, divide it by 1.008, that gives me $1,091.27, and that is the current gain that I have 10 days after initiation, or if you like, 20 days before expiry. Okay, so that is valuing a FRA. Now, what I thought we would then do is have a look at a question together. So I'm just going to bring up my whiteboard. And we're going to look at make the FRA a star. Again, if you downloaded the PDF and printed it out that the Netherlands Society sent you today, you'll find this towards the end of the PDF. So after the slides, you'll see that you've got both the questions, and because I was feeling generous, I actually gave you the answers. You've got two questions in there. Make the FRA a star, and I think the other one is something called Palmer or Plummer or something like that. Anyway, we're going to look at make the FRA a star because this essentially is based on FRAs. So we've got Elodie Brodeur working in a finance department of a large French fashion house. In fact, this is the first time that anyone's seen this question. I only wrote it a couple of days ago, or a couple of months ago. So it's brand new. So you're the first eyes to have had a look at this. Okay, so we've got Elodie Brodeur working for the finance department of a large French fashion house. The international catwalk season will start in 2 months' time. Elodie has worked out that the company will need a loan of $4 million starting in 2 months' time and lasting for 3 months to finance fashion shows. The company's finance providers are typically retail banks offering loans at Euribor, okay, plus 40 basis points. Okay, so Euribor is just Euro LIBOR essentially. So Euribor plus 40 basis points, and again, regardless of actual day counts for Euribor in our exam, it's always, regardless of your currency, 30 days in a month, 360 days in a year when you're looking at LIBOR, and simple rather than effective interest rates. So Elodie is concerned that interest rates may rise between the current time and needing to take out a loan. So we've got a scenario where she's taking out a variable rate loan in 2 months' time. So again, so we're looking at from day 60, that's where she's taking out her loan, lasting for 3 months. So 3 months is 90 days. So we've got the end of the borrowing and lending period in 150 days. So her loan period is 90 days from day 60 to day 150. And she's going to have to borrow at a floating rate of interest. Now remember, in order to hedge this, therefore, we're going to want a 2 times 5 FRA. So that's 2, the expiry date, okay, and that is 5, the end of the borrowing and lending period in months, okay. 30 days in a month. So 2 times 30 is 60. And of course, 5 times 30 is 150. So she's going to need a long FRA. Remember, if you're going to borrow at a floating rate in the future, in order to lock into a fixed interest rate, then essentially you want a long FRA position. Of course, if you're going to borrow at a fixed rate in the future and you want to convert to a floating rate, then you'd use a short FRA position. Annuity is trying to work out what the fixed rate should be on a 2 times 5 FRA before contacting her company's bank to arrange a contract. She always likes to check the terms of the bank offers reflect commercial rates. Elodie has collected the following details regarding Euribor. So there's our Euribor rates, 2% for 60-day, 90-day Euribor 2.4, 150-day Euribor 2.6, and 10-day Euribor 2.9. Upward sloping term structure, not massively surprising, but remember all those interest rates, of course, are annualized figures here. Elodie's counterparty bank has included a mark-to-market feature in the FRA where profits and losses are exchanged after 1 month of the contract in order to reduce credit risk. Of course, FRAs are over-the-counter contracts, and as we learnt at level 1, over-the-counter contracts are subject to counterparty risk. So here the bank is saying, hey, look, loser pays winner after a month to reduce default risk, essentially. And we've been given 1 month after the initiation of Elodie's FRA, we've been given the Euribor rates in Exhibit 2. Okay, so what have we got as our first question? At the expiry of the FRA, 90-day Euribor is 3.4%, we're also told. Okay. So which of the following comments regarding Elodie's required loan in 2 months' time is least accurate? A short FRA could be used to lock into a fixed rate of borrowing commencing in 2 months' time and expiring in 5 months' time. No. Okay, remember, if you've got a floating borrowing, if you're going to borrow at a floating rate in the future, you use a long FRA to hedge your position, because you need floating interest to come in on the FRA, and you use that floating interest to pay the interest on your loan, essentially. Okay, and therefore you've got a net position where you're paying fixed plus the number of basis points. So long FRA. That looks like our answer. I'm just going to check. B and C. The use of a FRA to hedge interest rate risk would lock Elodie into paying a fixed rate plus 40 basis points. Yes, the fixed rate, because remember, essentially you've got Elodie here, so here's her company. She's going to end up taking out a loan, and paying floating, and she's got a long FRA. Okay, so her loan will be Euribor plus 40 basis points. And of course, on the long FRA, she's paying fixed and receiving Euribor. So, of course, the basic idea behind this is this cancels with this, and we're left with paying fixed plus 40 basis points. So that all seems very, very true to me. So I think that is correct. Okay, remember, we're looking for least accurate. Okay, always worth underlining or things like least accurate. Now, I can almost hear you saying to me right now, we're doing a computer-based exam. We can't underline. Well, no, but you can highlight in the exam. Okay, so the Prometric software allows you to highlight, strike things out, etc. The use of a FRA to hedge interest rate risk, so this is C, use of a FRA to hedge interest rate risk on her future loan will mean she no longer benefits if interest rates fall. Absolutely. She's locked into a fixed rate plus 40 basis points. Doesn't matter now if LIBOR falls, she's still going to pay the fixed rate plus 40 basis points. So answer question 1 was A there. Right, let's have a look at question 2. Using the data in Exhibit 1, what is the closest to the forward price of a 2 times 5 FRA? Okay, so data in Exhibit 1, here's data in Exhibit 1, 2 times 5 FRA. Draw a timeline if you like to do that. So here we are at T0. It's a 2, so T60 is expiry of the FRA times 5. T150 is the end of the borrowing and lending period. Okay, so of course, she is locking into 90 days borrowing and lending. So we need a 90-day forward rate. So what we're going to need for this is 60-day LIBOR. So we need that one. And we need 150-day LIBOR. Anything else that we're given there in that table is just designed to confuse us. You know, I had a conversation with the examiner. This was a couple of years ago now. And he said during this meeting, he said, we never include information in questions that candidates don't need. And I said, yes, you do. You do include misleading information. And he said, oh, yes, but if a properly prepared candidate should be able to spot that the information is misleading or not needed, and therefore it's relevant because they should spot that it's not needed. Well, in other words, they do include irrelevant information. And in this question, the irrelevant information is the 90-day LIBOR and the 150-day LIBOR. So step one, we just need to unannualize those rates. So I'm going to do that now. So 60-day LIBOR, or Euribor, I should say, 2% times 60 over 360. I'm going to do 2% as decimal, so 0.02 times 60 divided by 360. And that gives me 0 as a decimal, 0.00333. Okay, so we've now got this rate here. If we do 1 plus that rate, we've got 1.00333. Okay, we do the same for 150-day LIBOR. So I'm going to do my 2.9%. This time I will write it as a decimal rather than a percentage. And we're going to multiply that by 150 over 360. Of course, that gives us the rate from there to there. So 0.029 times 150 divided by 360, and I get 0.01203. Let's see how many decimal places I have here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ah, 1, 2, 3. Okay, I've got 5 decimal places in both. That'll do. Examiner tells us that we should never need to work to more than 5 decimal places in the exam. Okay, so what we're trying to do is work out this mysterious rate here, the 1 plus the 90-day forward rate. And remember, as we mentioned, all we're going to do with this is take the long rate and divide it by the short rate. Okay, and remember, it's strictly speaking 1 plus the long rate divided by 1 plus the short rate. So what I'm going to do is 1.01208, the long rate, over 1 plus the short rate, 1.00333. Then, of course, subtract the 1 that we added, and then we need to annualize. It's a 90-day forward rate, so we're going to multiply by 360 over 90. So 1.01208 divided by 1.00333 gives me 1.00872. Subtract the 1. Okay, multiply by 360, divide by 90, and I've got a rate here of an answer of 0.0349. Okay, in other words, 3.49%. Let us go and see if that is one of our answers. And if it's not, come back and fix it. Let's have a look. What have we got? Closest to, don't have that. Let's just double check I didn't do something stupid. What have I done that's stupid? Have I got that LIBOR? Oh, it's that LIBOR 0.33333 was right. Oh, I see. It's LIBOR 150. Haha. Not 2.9% chump. It's 2.6%. Sorry. Throw in the occasional deliberate mistake to make sure you're awake. Ah, what a faff. Okay, it's going to make it lower. Going to make the answer 3%, isn't it? Sorry, let's try again. So 0.026 times 150 divided by 360. Okay, so we get a rate of 0.0108. So that would be 1.01083. Let's have a look at what happens now. So 1.01083 divided by 1.00333 minus the 1. So I've got 0.007475, then multiplied by 360 over 90. I got asked in a class in Dublin, in Ireland, do I have to do 360 divided by 90, or could I just multiply by 4? Alarming. I said, no, you can't multiply by 4. And they believe me. Okay, but of course you can. So we get 0.0299 or 2.99%. That's better. Okay, so is that one of our answers? Okay, closest to, and there'll always be closest to in the exam because it depends on your rounding. Okay, and the examiner is not really trying to trip you up on how many decimal places that you rounded to. Okay, so we're clearly closest to 3%. Right, question 3. So here is our tricky one. It says, assuming the forward price on the FRA was 2.9%. Okay, so it's saying assume that's your fixed rate. And they'll do this in the exam because we're never going to be reliant on the answer from a previous question to answer the next question. So in other words, what the examiner is saying here is, hey, I'm going to assume that you screwed up question 2 and got the wrong answer. So I'm going to tell you now an assumed fixed rate so that if you did mess up question 2, it doesn't have a knock-on impact into question 3. So we've got a fixed rate here of 2.9%. Okay, which of the following two is the closest to the gain or loss 1 month after initiation of the contract? Okay, so remember we were looking at a originally expiry in 60 days time. Now of course once 1 month has passed, expiry will be at T30 and the end of the borrowing and lending period will be at T120. So we're going to need T30 and T120 in order to do this. Okay, so we're going to use 1.8% Euribor and 2.8% Euribor. So let's have a go at doing this. Okay, I'm going to just scribble it in under here. I think I can fit it in a little bit. So we originally had T0, T60 and T150. 10 days have passed, so we're now, that becomes, if you like that, now becomes T minus 10. This becomes, not minus 10, minus 30, sorry, 30 days ago, 1 month has passed, and this becomes T30, and this becomes T120. Okay, and that is our valuation date, our new T0. So we need to take 30-day LIBOR and 120-day LIBOR and unannualize them. That is step 1 of this. So let's do 30-day Euribor. So I'm going to do 30-day, which was 1.8%. I'm going to simply need to multiply that by 30 over 360. And I'm going to need to do the same for 120-day Euribor. I'm going to need to take 2.8% and multiply by 120 over 360. So let's do that. So that gives me, as a decimal, 0.0015. Okay, so this rate here, 1 plus that is 1.0015. Then I need to do the same for the 120. 2.8 times 120 divided by 360. And that gives me, again, as a decimal, 0.09333. Again, 5 decimal places should do us in our exam. 1 plus that, 1.0933. So what we're going to then do is use this information to calculate what the new fixed rate would be for the original borrowing and lending period. Okay, so in other words, 10 days after initiation, when the original sorry, I keep on saying 10 days, 30 days after initiation, 1 month after initiation, when the original FRA now only has 1 month to expiry, what would be the new fixed rate on a FRA with 1 month to expiry and essentially 190-day borrowing and lending. Good. Okay, so again, we're still looking at 90 days. Remember, that's the length of time between expiry and the end of the borrowing and lending. So to get our 1 plus F90, okay, we're going to do 1 plus the long period rate. So 1.09333 divided by 1 plus the short period rate, 1.0015. Subtract the one we added, and then annualize. We're looking at a 90-day rate. Okay, these are unannualized amounts, so we then need to multiply by 360 over 90, and that will give us our new fixed rate. Okay, so let's do that. So 1.0 9. If I screwed that up again, am I just having a nightmare with my interest rates? I am, aren't I? That's another 0 in there. Sorry. I know what's going on with me today. Can't get my decimal points wrong. Right, so that should have been 1.00933. Okay, that's better. At least I spotted it this time before doing the computation. Okay, so I'm not quite sure why I'm messing those up. And that, of course, is always the danger in the exam, isn't it? Making some kind of silly mistake. Okay, so, right, let's do it. Work out the new fixed rate. 1.00933 divided by 1.0015. Subtract your 1. So I've got 0.0078182. Then I'm going to times it by 4 to get my new fixed rate of 3 points. Comes out at 0.03127 or 3.127%. Okay, now remember this question said, assuming the original fixed rate was 2.9. Okay, so original fixed rate 2.9, new fixed rate 3.127. So Elodie is going to have 1 because she's paying fixed interest at 2.9%, and a new FRA would be paying fixed interest at 3.127%. Our last little step here is just to work out the profit or loss for Elodie. I'm going to need a new page in order to do that. So here's our valuation date. Here's the FRA expiry. And here's the end of the borrowing and lending. Okay, so we do it as the new fixed rate because we're looking at the long party. And the new fixed rate, it'd be dangerous if I had a memory, or I've got it on my calculator. That's good. New fixed rate is 0.03127. The original fixed rate was 2.9%. Okay, got to be careful because those are annualized figures, so we just need to unannualize. We're looking at 90 days borrowing and lending. Okay, so we're going to multiply by 90 over 360. And then finally, we multiply by the notional principal on the FRA. I don't remember what that was. Let's just go back to the question. What is the notional principal on the FRA? How much are we borrowing and lending? Oh, there we go. There it was, 4 million euros. Okay, so we're going to multiply that by euro 4 million. So 0.03127 minus 0.029 times 90 over 360, which of course you could do divide by 4, same thing, and then times 4 million. And I get, on that, what do I get? 2,270, roughly. Okay, now all we then need to do is discount that back, because this is at 120. We need to discount it back all the way to our original borrowing and lending time. Original T0, in other words. Now, that, of course, is 120 days. So we're going to use 120-day LIBOR, which is our 9.333%. So all I'm going to do is divide by 1 plus 120-day LIBOR unannualized. 120-day LIBOR unannualized. What was that? It was 0.0933. And that gives me a value, again, to LOD of 2,249 euros, roughly speaking. So let's just check, see if that is close to one of our answers. So we're looking at 2249, or roughly 2250. 2249. We're a little bit out, aren't we? And I think that's because we've rounded to 4 decimal places, but that is going to be essentially our answer, 2265. So why were we out by so much? I think it's simply rounding. I think if I go back and add another digit to this, put a 3 there, which of course means this would change. Put a 3 there. Let's have a look at what that thing gives. I think the fixed rate would change just subtly enough to change our answer. So 1.009333 divided by 1.0015 minus 1 divided by, or multiplied by 4. I get 3.1. Oh, right there. Right. It actually bumps up my rate to 3.1285. And I think if I use that in my rates, then I'm going to get precisely the answer. Let's have a quick look. So if I change that to 0.031285, let's just see if that gives me a more accurate answer. So 0.031285 minus 0.029 divided by 4 times 4 million euros changes that to 2,285 divided by 1.009333. There'd be an extra 3 on there, wouldn't there? And that gives me 2,263. So you can see just at 1 decimal place rounding there, big change in my answer. Okay, so let's have a look. Does that get us closer to the correct answer? Yes, it does. You can see 2,265. But again, what I really want to stress there is I was closest with my answer. You know, when I did it one less decimal point, it still got me closest to answer C. So you need to be courageous, really, here, and realize that rounding does actually have a fairly significant impact on these questions. Right, let's have a look. Assuming the forward price of the FRA is 2.9%, what is the value of the FRA at expiry? Remember, FRA at expiry, there you go, there's 90-day LIBOR at expiry, 3.4% there. Okay, so we're going to have to value our FRA at expiry. This should be a relatively straightforward question to actually do. I think I can squeeze it in under here. Let's have a go at doing it under here. So, you know, we were originally at T0, we had T60 and T, what was it, 150. So we're now at expiry date, so time has passed. So essentially that becomes T0. That loses 60 days. That's now T90. Okay, good. Oh, sorry. Good. So remember, we are paying 2.9% and receiving Euribor. So we're going to receive Euribor 0.034. Okay, we're going to pay the fixed rate. We're told 0.029. We're looking at, again, 90-day borrowing and lending. So multiply by, unannualized by multiplying by 90 over 360. And then, of course, times our notional principal of 4 million euros. So 0.034 minus 0.029. Divide that by 4. Multiply by 4 million euros. And you've got essentially a gain at expiry here of 5,000. Get that again. So 0.034 minus 0.029 divided by 4 times 4 million. Okay, so we've got 5,000 euros. Now, of course, remember then the trick is that 5,000 euros is at day 90. And of course, remember they're actually exchanged at day 0 at expiry of the FRA. Okay, so you then need to just discount this back 90 days. So you take your 5,000 euros at the end of the borrowing and lending period, and you divide that by 1 plus 90-day LIBOR unannualized. So 90-day LIBOR unannualized, 0.034 times 90 over 360. So that gives me 0.0085. So I'm going to divide by 1.0085. And that will give me the value at the expiry of the FRA. So that gives me a value of 4,958. Okay, let's see if that is one of our answers. 4,958, there it is. Now, in practice, you can see one of the incorrect answers is the value of the FRA at the end of the borrowing and lending period. We're valuing the FRA not at the end of the borrowing and lending period, but at the FRA's expiry. So you do need to discount back from the end of the borrowing and lending period to expiry. And that's typical in forward rate agreements. So actually, once I'd spotted 5,000 was the end of the borrowing and lending, then I know actually that if I discount back for 90 days, it's going to be slightly smaller. So it had to be answer A. It certainly couldn't be answer C because that's bigger. Right, okay, that's all I want to do with you guys on FRAs. So what we're going to now move on to look at is swaps, okay. And as I predicted, I think we are going to run a little over time today. I think we're looking at probably 2.5 hours. So again, remember, if you need to drop after 2 hours, don't worry. This will be archived and you'll be able to pick it up and finish off anything that you didn't cover in the class. Right, let's have a look at swaps. So 3 types of swaps we're going to need to look at in the level 2 syllabus. we're going to need to look at the interest rate swap, we're going to need to look at the currency swap, and we're going to need to look at the equity swap. Now, the price of a swap is actually the swap's fixed rate. Okay, so we're going to need to be able to calculate the fixed rate. Now, what we're looking at when we look at an interest rate swap is and typically if we look at long interest rate swap, we're looking at pay fixed receive floating. Now, of course, you might immediately say that's the same as a FRA. That was pay fixed receive floating. Yes, but there is a subtle difference with interest rate swaps. We're paying fixed receivings floating at various settlement dates over the swap's life, whereas with a FRA, it was pay fixed receive floating as a one-off. The other big difference is at expiring, we don't discount the payments from the end of the borrowing and lending period back to expiry on a swap, whereas we do on a FRA. Now, when we come to price a swap, the present value of the fixed payments should equal the present value of the floating payments. In other words, there should be no gain or loss to either counterparty. Okay. Now, you can see swap value is the difference between the value of the fixed payments and floating payments. So key point is present value of fixed payments equals the present value of the floating payments at initiation. And this is important so that there is no gain or loss to either counterparty. But then after initiation, interest rates are going to change in the marketplace. So the present value of the fixed payments no longer equals the present value of the floating payments. And that's going to be how we determine value. So essentially, if you are paying fixed receiving floating, we actually value it after initiation by looking at the present value of the floating payments, what you're going to receive, and deducting the present value of the fixed payments, what you're going to pay. So often they talk about payer and receiver swaps. Just be aware that a payer swap is pay fixed receive floating, and a receiver swap is receive fixed and receive fixed and pay floating. So payer and receiver are always from the fixed payment point of view. Payer swap, pay fixed. Receiver swap, receive fixed. Okay, so just watch out for that terminology that you might see crop up in the exam. Now, this is important, replicating swaps. There's three ways you can actually replicate swaps. You can either use FRAs, off-market forward rate agreements, in fact. You can use FRAs. You could use interest rate options, long call, short put creates a FRA, or you could use bonds. And the bond one is important because that's the mathematics that drives swaps. In other words, if a payer swap is pay fixed receive floating, I could replicate that by issuing a fixed coupon bond. I'm now paying fixed coupons, taking the proceeds from my fixed coupon bond and buying a floating rate note. So I'm now paying fixed on the bond that I've issued, and I'm receiving floating on the bond that I purchased. Okay, so this is absolutely critical. Okay, it's all about replication with bonds. If you understand that, you will understand the pricing and valuing of swaps without any real problem, even the currency swap. Now, next thing to say is, what do we know about floating rate notes? What do they trade at when they're created and at every coupon reset date? They trade at par. So at initiation of the swap, the present value of the floating payments is equal to par value. What that means is the present value of the fixed coupon bond must also be par at initiation, so there is no gain or loss. Okay. So the swap fixed rate must be set so that the swap value at initiation is 0. Key point. Okay. We know a floating rate note trades at par at initiation and at each coupon reset day. Okay. So we're going to value our swap and price our swap as a combination of fixed rate bond and floating rate note. So notice the value of a payer swap, pay fixed, receive floating, is the value of the floating rate note that you're receiving minus the value of the fixed coupon bond that essentially you're paying. Now, at initiation, the floating rate note trades at par. Okay, remember, it's only a theoretical floating rate note here. But the value of the floating side must equal par. What that means is the value of the fixed coupon bond must also equal par. In this situation, I've got a par value of $100. Now, what we're going to be told is what LIBOR rates are. So these are just our unannualized LIBOR rates over the swap's life. We know you get back par. The only thing we don't know is what the coupon rate must be on our fixed coupon bond, so that when we discount those coupons and the final payment of par, we end up back at par value. So the coupon rate is the unannualized swap fixed rate. Okay, that is the coupon rate on your fixed coupon bond. Now notice what we've then done is we've changed from having a bond of $100 to assuming a $1 par value. So what we're then saying is, look, the coupon rate's discounted plus the final payment of par of $1 discounted back to T0 must equal 1. Now, they also then introduced the idea of discount factors. So discount factors are simply 1 over 1 plus your unannualized LIBOR rates. Okay. So what you then get is this formula. Knowing that the fixed coupon bond has to trade at par, you get the coupon at time 1 times discount factor 1 plus the coupon at time 2 times discount factor 2 plus the coupon at time 3 times discount factor 3 plus the coupon at time 4 times discount factor 4 plus the par value times discount factor 4 has to equal par. And if you rearrange that, you get the coupon rate on the bond, the unannualized swap fixed rate, is equal to 1 minus the final period's discount factor divided by the sum of the discount factors. And that is how you work out the fixed rate in a swap. It's how you work out the fixed rate in an interest rate swap. It's how you work out the fixed rate in a currency swap. It's how you work out the fixed rate in an equity swap. In fact, it's always how you work out the fixed rate in a swap. So it's an absolute must-know formula. Now, does it matter about understanding how to kind of rearrange the earlier formulas together? No, just learn it. 1 minus final period's discount factor divided by the sum of the discount factors. Okay, and there you go. So the swap's fixed rate, 1 minus the final discount factor over the sum of the discount factors. That will give us the unannualized coupon rate. The swap fixed rate is then quoted as an annualized figure. So we then multiply by settlement periods per year. So if this was a quarterly swap, we'd multiply by 4 quarters in a year. If it's a semi-annual swap, you'd multiply by 2. If it's an annual-based swap, then you don't need to multiply by anything, or multiply by 1 if you like. Okay, so it's always settlement periods per year. Notice it's settlement periods per year, so how many settlements per annum, not the life of the swap. Right, okay, so let's actually have a look at computing a swap fixed rate. So we're going to calculate the swap rate and the fixed payment on a 1-year quarterly settlement swap. So 1 year, that's the tenor of the swap, just means the current life of the swap, 1 year. It's quarterly settlement, so payments are every 90 days, or settlements are every 90 days, and we've got a notional principal here of 10 million. Now, what we've then been given is at initiation of the swap, we've been given LIBOR that relates to each settlement date. So 90-day LIBOR, 4.5%, 180-day LIBOR, 5%, 270-day LIBOR, 5.5%, and then finally the final settlement date, 360-day LIBOR, and 6%. Now, what we then need to do is convert these into discount factors. Okay, now this is relatively straightforward. So what we're going to do is take the annualized rate. Let's start with 90-day LIBOR. Take your annualized rate, 4.5%, multiply it by 90 over 360 to unannualize. So again, do this as a decimal. So 0.045 times 90 divided by 360. And that gives you, as a decimal, 0.01125. And then you'll notice, in order to compute your discount factor, otherwise known as the Z factor, it's simply 1 over 1 plus your unannualized LIBOR. Now, what does a discount factor do? Well, if you took a cash flow at day 90 and multiplied it by the discount factor, it would give you the present value. Okay, 180-day LIBOR, well, that's going to be 1 over 1.025. Okay, 5% is the annualized rate. 180-day is going to be 2.5%, so 1 over 1.025, and you've got your discount factor. 5.5, you'd need to multiply by 270 divided by 360, and that would give you 4.125%. 1 plus that, so 1.04125. Take the reciprocal and you get 0.96038. And then finally, 360-day LIBOR. No need to unannualize that. Sorry, it's just going to be 1 over 1.06. Okay, so make sure, I think in the exam, examiner is likely to give you discount factors, but often maybe one might be missing. Okay, so you just be aware of how you calculate those discount factors. Right, I've got my discount factors, so now I need to plug them into my magical formula to get the swap fixed rate. Now remember what that will do, 1 minus final period's discount factor over the sum of the discount factors, that will give me the coupon rate on the bond. Okay, now be careful, okay, this is a quarterly paying swap. So there are 4 coupon dates in a year. So what we're going to need to do then is multiply our answer by 4 to get the swap fixed rate. And again, that is because fixed rates are always quoted annually. So notice, quarterly rate, when you do that calculation, is 0.01463 or 1.463 as a percentage. That's the coupon rate, the quarterly rate on your bond. Then, of course, we need to annualize that, which is what we're doing at the bottom of the slide. Take your 1.463. There are 4 quarters in a year. So multiply by 360 divided by 90, otherwise known as 4. And that gives you the fixed rate on your swap of 5.852%. So it's always going to be quoted as an annualized number. Lovely. Right. Okay. Now, what is the quarterly fixed rate payment? Every quarter, the fixed rate payer is going to be paying the coupon rate on the bond. So take your swap's fixed rate, unannualize it. Okay, so we're just back to this rate here. Multiply by the notional principal. Okay, so on this bond with a notional principal or par value of 10 million, we're going to be paying a coupon of $146,300 every 90 days. Okay, if we're paying fixed, and of course we're going to be receiving floating. Right, now we're going to value a swap. Okay, so we know how to get the fixed rate. We're going to value a swap. Now remember, all we said was the present value of floating minus the present value of fixed is equal to 0 at initiation. In other words, the floating rate note is equal to the fixed coupon bond at initiation. However, once initiation is passed and interest rates start to move, the present value of the floating side no longer equals the present value of the fixed side, and the difference is, or the value of the swap is simply the difference between these amounts. So what we're going to do is calculate the value or the present value of replicating the fixed rate bond, calculate the present value of replicating the floating rate note. Now, here is a beautiful thing about interest rate swaps in the level 2 syllabus. We are only required to value an interest rate swap at a settlement date in the swap's life. Okay, now, what do we know about floating rate notes at settlement dates, at coupon dates? They trade at par. So therefore, the present value of the floating rate note in our exam will always be at par when we come to value it, because we only are required to value floating rate notes at settlement dates, and they're always at par. Now, when I did my CFA exam, we had to value floating rate notes between settlement dates. Okay, and of course, in that situation, your floating rate note isn't necessarily trading at par, but that has been removed from the CFA syllabus. So remember, nice and simplified here, you only have to value an interest rate swap at a settlement date. Interestingly enough, when it comes to currency and equity swaps, you're expected to be able to value those between settlement dates. Okay. So this is the syllabus, this is the formula that the CFA syllabus gives you. And I think this is totally unintuitive, okay? It's correct, don't get me wrong. So what they say is the value of a payer swap is the sum of the discount factors times the new fixed rate on a swap minus the old fixed rate on the swap divided by the number of settlements per year. That's simply unannualizing times notional principal. It's completely true, okay, but it's completely counterintuitive. So what I want to do is take you through an alternative method of calculating swaps, interest rate swaps, the gain or loss on an interest rate swap, the value of an interest rate swap. And the reason I want to take you through that alternative method is it will then be 100% consistent with currency swaps and equity swaps. Whereas this formula they're giving you here only works for interest rate swaps, and more to the point, it only works for interest rate swaps if you are at a settlement date. Okay, if you're between settlement dates, this formula would not work. Okay, so notice we're looking at the same swap priced at 5.852%, but we're assuming 180 days have now passed. So that means the payment at day 90, or the settlement at day 90 has taken place, the settlement at day 180 has taken place, so we've now got remaining the settlement at 270 and the settlement at 360. Now, of course, if 180 days have now passed, there's now only 90 days remaining until we get to day 270, and 180 days remaining until we get to day 180. So what they've then given us, therefore, is the remaining LIBOR rates. They've given us 90-day LIBOR, 3.5%, and 180-day LIBOR, 4.25%. They've unannualized those and converted them into discount factors for us, which is rather nice. Okay. Now, as we said, you are only numerically tested on valuing an interest rate swap immediately after a settlement date. Okay. Computations between payment dates have been removed from the syllabus, so you do not have to worry about that. Okay. And the reason is they don't tell you how to value floating rate notes between settlement dates. That's gone from the syllabus. It's actually really easy. I don't know why they took it out, but they did. Okay. Right, so here is valuing our swap at the valuation date. Now remember, our swap's fixed rate, 5.825%. I can't even remember the notional principal on this swap now. I'm going to have to go back. Sorry. 10 million. 10 million. Okay. So if we work out the coupons on our pretend fixed coupon bond, take the 5.825%, divide it by 4 because we're looking at 90-day settlement. So 5.852 divided by 4, that takes us back to our 1.463%. And if we take 1.436% of our notional principal, which was 10 million, we get our coupons on our pretend fixed coupon bond that we worked out earlier of 146,300. Okay. So notice, here's our fixed coupon bond then. So in day 90, remember that was originally day 270, but 180 days have now passed. So at day 90, the fixed coupon bond pays out another coupon of 146,300. At day 180, it pays out its final coupon of 146,300 and returns its par value of 10 million. Now, what we're then going to do is we're going to take these discount factors and just use them to discount back to our current valuation date. So the first cash flow here gets multiplied by 90-day LIBOR, and it has a present value of 145,032. We then discount back 10,146,300 by 180-day discount factor of which is 0.97919. That gives us a value of 9,935,155. Add them together, and that is the value of the fixed coupon bond at day 180. Okay, current value at our valuation date, which is day 180. Now, what is the value of the floating rate note? Well, because we're at a settlement date, the value of the floating rate note equals par, i.e. 10 million. So we can finish this off, therefore. We know the floating rate note has a value of 10 million. Therefore, the value to the fixed payer, they are paying fixed, receiving floating. The value of the floating rate note is par value, 10 million. The value of the fixed coupon bond, we just worked out to be 10,080,188. Difference between that is minus 80,188. And that, therefore, is the loss to the payer, fixed rate payer. They're paying fixed, receiving floating. That's how I really think of interest rate swaps. I think of them as two bonds. One's a fixed coupon bond, one's a floating rate note. Value the fixed coupon bond, compare it to the floating rate note, which will always be trading at par at each settlement date, and the difference is the value of your swap. Now, what about the CFA Institute's formula? What they do is they say, compute the new fixed rate on a swap at the settlement date. So 180 days have passed. We've now got 90 and 180 days remaining to the last cash flows. So what we do is 1 minus the final period discount factor, that's 180-day discount factor, over the sum of the discount factors, which is the 90-day and the 180-day discount factors at our valuation date. Okay, all of those, that will give us a 90-day fixed rate. We then need to annualize it by multiplying by 360 over 90. So what that is then saying is a brand new swap that has the same payments as, or the same settlements as the settlements that remain on your original swap would have a rate of 4.224%. Okay, so this new swap has got the same payment dates as your original swap. Okay, so in other words, what they now do is they say, take the new fixed rate, which we've computed on our valuation date using the remaining 90-day and 180-day LIBOR, so 4.224%, minus the original fixed rate that you locked into on your swap 180 days ago, which was 5.852%, unannualize those, so multiply by 90 over 360, because the swap fixed rates, of course, are calculated as annualized rates, and then multiply by your notional principal. Now, what that therefore tells us is, minus 40,700. What does that mean? Well, per the CFA's formula, it's saying you are $40,700 worse off, because in your swap, you're paying at fixed interest at 5.852%, whereas a new swap would be paying fixed interest at 4.224%. Okay. So that's how much we are worse off at each of the remaining settlement dates. Now, all we need to do then is take that 40,700 and discount it back to our valuation date. Okay, and that will give us the value of the swap overall. So there you go. Those are the two amounts. Take the first one back at 90-day LIBOR. That gives us minus 40,347. Second one comes back at 180-day LIBOR, which is 0.97919, which gives us 39,853. Add those up, and you get minus 80,200. Okay, now that essentially is the same as we got using our approach back here. Look, we were $12 different, and that is simply due to rounding in the discount factors to, in this case, to 5 decimal places. Okay, if you didn't do that, if you had no rounding in your discount factors, you would get exactly the same answer. So get 80,200. Now, actually what the CFA syllabus does is, look, first step of their computation, this bit here, this is just giving us the minus 40,700. Okay, in other words, this and this. Now, what they're then doing is adding these two discount factors. So taking this discount factor and this discount factor, adding it together to get an annuity factor. Okay, and of course, annuity factors, you're very comfortable with level 1. Take an annuity factor and it will discount equal payments back to your valuation date. So all they're doing is multiplying by 1.97052, so 40,000 minus 40,700 times 1.97052, and there you go, you get the answer, minus 80,200. So I'm totally happy if you want to use the CFA Institute's formula, okay, but note it is doing exactly the same as our approach where we looked at the fixed coupon bond and the floating rate note. And I think that is more intuitive to look at the fixed coupon bond and floating rate note, because that's what you're going to do with currency swaps and equity swaps. Okay. Lovely. Okay, that's just another way of writing it out that we've seen before, so I'm not particularly excited by that. Right, let's move on to currency swaps. So the interest rates used to price currency swaps are the swap rates calculated from each currency's term structure. So what is that telling us? It's nothing telling us, not really telling us a lot, really. All it's simply saying is, if you're working out the fixed rate, you just use each country's LIBOR rates, okay, each currency's term structure. Now, with a currency swap, of course, the motivation is to borrow in a cheap currency and swap it for the currency that you actually want. So principal amounts are exchanged at initiation and at maturity. Okay, now the valuation approach that we're going to use is going to be very, very similar, but we're going to adjust payments for exchange rates. It's going to be very nice and straightforward. Okay, now we're going to look at the US dollar euro fixed for fixed. Now, essentially, if they're going to give you fixed versus fixed currency swap, then essentially they can do it between settlement dates. If one of the sides is going to be floating, they would have to do it at a settlement date. You'd have to be valuing at a settlement date because the syllabus doesn't tell you how to value floating rate notes between settlement dates. And remember that formula that we saw from the CFA Institute only works at a settlement date. So if one of your sides is a if one of your sides is variable, then they will be testing these computations at settlement date, and therefore the floating rate note side is par. Anyway, let's have a look at this. We're looking at a US dollar euro fixed for fixed 2-year semi-annual swap with $10 million of notional principal. It's initiated when the exchange rate is $1.05263 per euro. US dollar rate fixed rate is 3%, and that will have just come from dollar-based LIBOR, and the euro fixed rate is 2%, and that will have come from Euribor. Using the same formulas that we've seen before, 1 minus the final period discount factor over the sum of the discount factors. Okay, now first of all, what you need to do is work out what the dollar principal is in euros. So all you do is you use the exchange rate at initiation. So in this case, 10 million US dollars divided by 1.05263, and that gives me 9.5 million euros. Okay, so whoever is paying fixed dollars, dollar rate 3%, they're going to pay 3%, but it's semi-annual. Let's be careful on that. Semi-annual swap. So they're going to pay 3%. So notice we've taken 3%. That's the annualized rate in the swap. It's a semi-annual swap, so we've multiplied that by 180 over 360, or if you like, divide by 2, times your notional principal of $10 million, and therefore the dollar fixed payments are $150,000 per period. Euro fixed payments, take your 9.5 million euros and multiply by your euro fixed rate of 2%, but again, make sure you've unannualized by multiplying by 180 over 360. So 9.5 million euros times 0.02 times 180 over 360, and therefore the euro interest is 95,000 euros each semi-annual period. Now, let's work out what's going on here. So we've got two, these are looking at how the currencies are exchanged. So we've got counterparty A. Now, counterparty A is going to be in the US. And counterparty B is going to be in the Eurozone. Now, counterparty A, the US firm, wants to receive euros at initiation. Maybe it wants to invest somewhere in Europe. But it's going to find it expensive to borrow euros because it's not got an established credit rating in Europe. So what it does is it goes out and borrows in its domestic currency. So what it's going to do is it's going to borrow $10 million US. And once it's borrowed the 10 million US dollars, counterparty A is exchanging it for 9.5 million euros. Now, at the same time, the counterparty B in the Eurozone, what they're going to want is US dollars. But again, they find it prohibitively expensive to borrow dollars. So what they're going to do, yeah, my dog's just pushed its way in. Hey, baby. They're going to borrow 9.5 million euros. Okay, so counterparty A, based in the US, borrows in its domestic currency. Counterparty B, based in the Eurozone, borrows its domestic currency. They then exchange it for the currency they want. In other words, counterparty A passes the $10 million to counterparty B in exchange for 9.5 million euros. Now, and this is very critical, at the settlement dates on your swap, day 180, day 360, day 540, day 720, counterparty A will be paying the euro interest. Now that means counterparty A is the euro payer in the swap, and counterparty B is the dollar payer. So why is counterparty A paying euros to counterparty B? Because counterparty B has borrowings in euros and needs to pay the interest to the bank it borrowed from. So counterparty B receives 95,000 euros from counterparty A and uses it to serve its debt, the interest on its debt. Now, at the same time, counterparty B is paying $150,000 to counterparty A. Counterparty A receives this interest and uses it to pay the interest on its $10 million US loan. Okay, so notice payer and what currency, when they talk about, oh, you're the euro payer or the dollar payer, it's not from T0's perspective. It's not from the perspective of the currencies that were swapped at initiation. It's from the perspective of the interest payments and principal payments over the remaining life of the bond. So counterparty A is the euro payer, counterparty B is the dollar payer. Now, of course, at the end of the swap's life, that's day 720, they then swap back the principal. So counterparty A passes 9.5 million euros to counterparty B. What does counterparty B do with that? Pays off its borrowing. And counterparty A receives $10 million from counterparty B. What does it do with it? It pays off its borrowing. Okay. So the whole motivation behind the currency swap is to borrow in a cheap currency, normally your domestic currency, and swap it for the currency that you actually want. Okay, that's your motivation. Right, currency swap valuation. How to calculate the fixed rate? As we've said before, it's just using the same formula, 1 minus the final period's discount factor over the sum of the discount factors. Okay, so we're going to continue our currency swap example. And the currency swap example, let's just go back and remind you of it. 2-year semi-annual swap, 10 million US dollars, equivalent to 9.5 million euros, 3% fixed on the dollar side, 2% fixed on the euro side. Okay. Now notice we're valuing now. We're going to have to value our swap. And notice this is the exchange rate on the date of the valuation. And we've been given some current dollar LIBOR. So there's our dollar LIBOR rates. We're 270 days after inception. Now remember, originally on our swap, we had payments at day 180, day 360, day 540, and day 720. Now, if 180 days have now passed, the payment, if 270 days have now passed, the payment at day 180, that's gone. Okay, and the payment at original day 270 is now 90 days away. The payment at original day 540 is now 270 days away, and the payment at original day 720 is now 450 days away. So we've been given LIBOR for 90-day LIBOR, 270-day LIBOR, 450-day LIBOR at our valuation date, and we've been given Euribor at those dates as well, and we've been given the discount factors. So we need to value the swap from the perspective of counterparty A. Now, counterparty A, remember, was the euro payer, as we said. So they're going to be paying euros and receiving dollars. So first of all, what we're going to do is look at the present value of the dollar side. Now, remember, we earlier calculated the coupon on the fixed coupon bond, on the fixed dollar coupon bond, as 150,000 each settlement date. So there they are. And the final notional principal or final principal amount of 10 million. All we're now going to do is discount them back to our valuation date by multiplying through by the 90-day discount factor, the 270-day discount factor, and then finally the 450-day discount factor. Add them up, and that is the value of the fixed dollar payments. So $10,990,823.40. Okay, what we then do is exactly the same for the euro side. So here are the coupon payments on our euro side: 95,000, 95,000, 95,000, and the remaining settlement dates are in 90 days time, 270 days time, and 450 days time. And of course, the notional principal on the euro fixed bond was 9.5 million euros. Now we're going to discount those back to our valuation date using Euribor. So multiply by 90-day Euribor, multiply by 270-day Euribor, and finally 540-day Euribor. For some reason that 90-day Euribor is missing. Let me go and retrieve 90-day Euribor from the question. Where was 90-day Euribor? Here it was. That's what we were multiplying by. I'll just put that one in there for you. There you go. Now that gives us the value of the bond in euros. But what I can't do is compare the present value of the dollar bond, which we calculated in dollars, to the present value of the euro bond that we've calculated in euros. Now remember, we're valuing this bond from counterparty A's perspective. And counterparty A essentially is paying the euros and receiving the dollars. Now what we're going to do, therefore, is we're going to convert the value of the euro bond into dollars. And we do that using the exchange rate at the valuation date, okay? A lot of people want to use the original exchange rate at initiation. And I think that's because they've learned that on a currency swap, the principal flows are swapped at initiation and at expiry of the swap at the same exchange rate. And that's true. That's not what we're doing here. All I'm saying to you is at the valuation date, the value of the euro bond is 9.561 million US dollars. 9.561 million euros. What is that worth in dollars at the valuation date? So you use the exchange rate at the valuation date, always. So take your euro bond, multiply it by the exchange rate. There is 1.0911 US dollars per euro, and that gives you the value of the, this is the value of the euro bond. So this is our euro denominated bond in dollars. Okay. Now, finally, we then need to compare the two bonds to work out the gain or loss from our counterparty. Now, remember the value to counterparty A. They were receiving US dollars and paying the euro. Okay, paying euro interest and then final swapping the principal back. So the value of the US bond, which we're receiving, 10,090,824.24. And the value of the euro bond, a euro denominated bond, $10 million, 432,957.07. Difference between them, minus 342,132.83. That is the loss that counterparty A has made on the swap, okay, at the current valuation date. Now they've made that loss, and therefore, of course, the other counterparty B, has got a gain of that amount. Good. The final one is equity swaps. Now, equity swaps is the easiest of all. Okay, we're still going to work out the value of our swap as the present value of what you're receiving minus the present value of what you're paying. The swap's fixed rate, if it's a fixed for fixed for equity return, is still calculated using the same formula: 1 minus the final period's discount factor over the sum of the discount factor. Now, again, I think of equity swap as pay fixed, receive floating. It's just that the floating rate isn't based on LIBOR this time. This time, the floating rate is going to be based on an equity index. And in fact, that makes it so easy to compute, because the value of the index side is simply the return on the equity index times the notional principal since the last settlement date. Let's go through it. Now, who pays what? Again, this is doesn't actually have any implication to the questions that you're going to answer in the exam. So it doesn't affect your calculations, but it does have a potential ability to come up in narrative-based questions. Now, what we're doing, equity return payer, is they are paying the equity return and receiving a fixed rate. Okay, so they're going to pay any positive return on equity. They're going to receive fixed rate payments. But how do you pay a negative return on an equity index? Well, you pay a negative return by receiving it. So potentially the equity return payer will receive the fixed rate, but they will also receive any negative return on the equity index. Now, the fixed rate payer, they're paying fixed and receiving floating. So they're going to pay the fixed rate, but they will also pay any negative return on the equity index, and they will receive, of course, any positive return on an equity index. Valuation, as I said, is exactly the same as we've done before. Present value of what you're receiving minus present value of what you're paying. Now, here's how we work out the present value of the equity side. It's simply the index level at the valuation date. Okay, so this point is at valuation. And the index level, the stock market index, at the last settlement date. In other words, by doing current index level divided by index level at the last settlement date, what we actually are computing is 1 plus holding period return. And then you just multiply that by your notional principal. There is no discounting involved, because all we're looking at is the change in the equity index from the last settlement up to our valuation date. Again, our valuation date is at the new T0, if you like. So it's already in present value terms. Okay, so let's have a look at a little computation here. So we're looking at a 1-year quarterly equity swap. We're paying a fixed rate of 5.852%. That was the fixed rate in our interest rate swap earlier. And we're receiving a return on the equity index. Now it says day 180 was the last payment date, and the equity index was 1,400. We're now at day 240, and remember, it was originally a quarterly swap. So it originally had payments at day 90, day 180, day 270, and day 360. It's saying now we're at day 40, which means there's now 30 days to this payment, and what is that? 120 days to that payment. Now notice it tells us now the index on day 240, where we're trying to value, our index value is 1,300. We're then told 30-day LIBOR, okay, and given its discount factor, and 120-day LIBOR, and given its discount factor. And we're asked to value the swap on day 240. Now this information here, the LIBOR rates and discount factors, is only used to value the fixed side. Value the floating side is simply going to be the change in the equity index. So at the valuation date, 1,330, compared to the last settlement date, 1,400, times the notional principal, which I think is 10 million, but we're going to look at that in a second. Okay, so let's have a go at doing it. So our fixed coupon bond, there you go. There's your cash flows, 146,300 and 10,146,300. Those numbers should be familiar to you. Those were the numbers that we had earlier when we were doing our fixed coupon bond. Remember, again, I think it's probably worth just saying, here we are at our valuation date. We've got a cash flow in, what did we say it was? 30 days time. And the final cash flow in 120 days time. The fixed rate, 5.852%. Okay, so to work out your coupons, 5.825% times 90 over 360 times your notional principal of 10 million. Okay, and that's where you get essentially your coupons. There's been a slight bit of rounding here that I'm not particularly happy with. 5.825% divided by 4 times our notional principal. I get 145,625. So actually, I'm going to change this. I'm going to correct this. I think that should be 145. I'll just check I was right with the 5.825% before I go ahead and change something. Yeah, 5.852%. That's the rate they've given us. Same as the interest rate swap example. Is that the same as the interest rate swap example? Let me just go back to that. The interest rate swap example. And we had, I think it's just rounding. 5.852. So 5.852 divided by 4, 1.463 times 10 million. Okay, okay, right. The numbers are right. I'm just going crazy. Too long staring at a computer screen today. Sorry, so let's get back to our numbers. So 5.852. Because I wrote that down wrong, didn't I? 5.852. There we go. It's me all along. What a surprise. So 0.05852 divided by 4 times by 10 million. And you've got, therefore, your coupon payments of 146,300, 146,300, and then the repayment of par, $10 million. Okay, so our computation here, let's get rid of that because that was right. Okay, all we're going to do is that's being discounted that back by multiplying by this rate here, 0.986, 0.98684, and these two cash flows here, 10,146,300, are coming back by actually these are being discounted back at the point. These are being multiplied by 0.98684. These ones here are being multiplied by 0.99751. So those are just the discount factors coming from 30-day LIBOR and 120-day LIBOR. And that gives us the value of our fixed coupon bond. 10,158,710. Now, the equity index, notice, is just the value, the index value at your valuation date compared to the last settlement date. So 1,330 over 1,400 times your notional principal, 10 million, and that gives us 9.5 million. So the value of this swap, they are paying fixed and receiving the equity return. So the equity return is worth 9.5 million. Okay. The fixed payments are worth 10,158,710. So therefore, the equity return receiver has lost 658,710 on this swap. Fabulous. Okay, that's the last slide. So last thing we need to do then is go through a final question. So we're going to have a look at what I consider to be a very, very tricky question indeed. And largely it's because it was built really to demonstrate all of these computations rather than to be like an exam question. And I think it even gives you a bit of a health warning on it. So let's have a look. So scroll down. Again, you've got this question. The question we're looking for is Palama PLC. And this is a particularly tricky one. And notice, look, there's a professor's note at the top saying you're not going to see anything as computationally as heavy as this. This was built really to test people's understanding. Okay, so let's have a look at the question. Palmer PLC is a swaps trader, bullish on the FTSE 100 over a medium future, over the medium term future, due to loose monetary policy of the authorities. Okay, so increasing money supply and therefore interest rates dropping, and that should stimulate your equity markets. They're considering entering a 2-year semi-annual equity return swap as the equity return receiver. Well, of course, if you're bullish on an equity index, then you want to receive the returns. So they're entering a 2-year semi-annual equity return swap as the receiver, and it's got a notional principal of 50 million. So again, if I was in the exam, I'd be highlighting. Maybe I should use my highlighter then to kind of replicate what you guys will be able to do. So I'll be highlighting key factors in here. I'd be saying, okay, 50 million. Oh yeah, look, 2-year semi-annual, that's important there. 2 options, one as a fixed rate payer, one as a variable rate payer. Okay, we've got the value of the equity swap when we entered into it. Okay, that's important. Palmer have almost finished computing discount factors based on the current UK term structure of interest rates. The following exhibit summarizes their computations. And notice we've got exhibit 1, which has got the current UK term structure. Those are our LIBOR rates. And remember, it's a 2-year semi-annual swap. So we've got LIBOR, 180-day LIBOR, 360-day LIBOR, 540-day LIBOR, and then finally 720-day LIBOR. And they've been converted into discount factors, but what a shock, the final one is not there. So we may as well just complete this whilst we're going along. So what we've got to do is take 5.56, that's the annualized 720-day rate, annualize it. Now people are scared about annualizing rates that are more than a year, but you use the same logic as unannualizing rates that are less than a year. So you multiply in this case by 720 over 360. So 5.56 times 720 over 360 times 2 gives me 11.12%. My missing discount factor is therefore going to be 1 over 1 plus my discount factor, 1 plus unannualized LIBOR as a decimal. So 1 plus 0.1112. And that gives me, how many decimal places are they using? 4 decimal places. So I will have a rate of 0.8999. Okay, there you go, 0.8999. So we've just filled that in as we've gone along. Now, 135 days later, so again, key information here, 135 days later, the FTSE has risen to 6,786. And the term structure of interest rates is now, today's day 45. Okay, remember originally, the first payment was at day 180. If 135 days have passed, the first payment is now 45 days away. The second day payment was at day 360. Deduct 135 days, so that's now 225 days. Third, 540, deduct 135 days, so that's now 405 days away. And then, of course, the final amount was originally 720 days. Again, deduct 135, it is now 585 days away. Okay, so those are the LIBOR rates used for the remaining settlement dates on our swap. We're also told that Palmer is concerned about the loose monetary policy will lead to falling interest rates and considers entering a semi-annual paying interest rate swap as the fixed rate receiver. I'm just going to highlight there the fixed rate receiver. So they'll be receiving fixed and paying floating. Spot rates at the time of the initial swap were given in Exhibit 1, and it had a notional principal of 50 million. Okay, so I'm just going to again note that. Remember, you have got the ability to highlight in the computer-based exams. 180 days have now passed, and the term structure for the remaining payment dates on the swap's live. So notice this date, this time we're looking at 180 days. Going back to the previous slide, it was a semi-annual interest rate swap. Okay, and it said spot rates when you entered the swap were given in Exhibit 1. So it must have been a 2-year semi-annual swap. Now, if 180 days have passed, What that means, of course, is we are now at the first settlement date. So we've got the second settlement date, the third settlement date, and the fourth settlement date remaining. Is that a surprise? No. Remember, they will only ever ask you to value interest rate swaps at a settlement date, because their formula that they've given you in the Institute's material does not work between settlement dates. Okay, so let's have a look. Exhibit 3 is the interest rates 180 days later, so we're obviously going to use those to value the interest rate swap. Palmer was also bullish on the pound versus US dollar and entered it into a 2-year currency swap with semi-annual payments, making payments in the US dollar. Okay, so I'm going to just highlight that they're making payments in the US dollar. Okay, the swap is based on notional principal of 25 million. It's paying 5.3% fixed on the pound and 5% fixed on the US dollar. And the exchange rate was $1.64 per pound. Okay, that's all going to be very useful for me. 135 days later. Okay, so of course, 135 days later, the first settlement is now 45 days away, the second settlement 225, the third settlement 405, and the final settlement 585. And we're told the exchange rate there as well. Okay, and here are the US dollar exchange rates that we are going to need to answer our question. We've got the sterling exchange rates for the UK sterling fixed side in Exhibit 2. Sterling interest rates, I should say. Right, okay, so first of all, using Exhibits 1 and 2, the value of the equity swap described in option 1 on day 1 through 5. What was option 1? Oh, there you are. Enter the swap as a fixed rate payer. So we're looking at pay fixed and receiving the floating return on an equity swap. And we've got all of those lovely term structure of interest rates there. So given that we're trying to value our swap, pay fixed, receive floating, one of the first things we're going to need to do is work out what the fixed rate is. And to do that, all I'm going to do is use the rates in Exhibit 1, i.e. the term structure when the swap was created. And we know we calculate the swap's fixed rate, let's call it the SFR, swap's fixed rate, as equaling 1 minus the final period's discount factor over the sum of discount factors. So 0.9815 plus 0.9594 all the way up to 0.8999. Okay, now remember the payment dates are every 180 days. There are 2 lots of 180 days in a year, so we multiply by 2 to get the swap's fixed rate. Otherwise, the fixed rate would come out as a 180-day rate, and we never ever essentially use those. Okay, everything is always going to be annualized. It's just essentially what we do. So let's work out our swap's fixed rate here. Doesn't tell us the fixed rate in the question to use, does it? No, it just tells us value the equity swap in option 1. Okay, fair enough. So let's do this sum then. 1 minus 0.8999. Store that over 0.9815 plus 0.9594 plus 0.9317 plus 0.8999. I'm going to store that on my calculator. Equal 1 divided by equal 2 times 2. And I've got a rate of about 5.31%. Okay. So about 5.31%. I think that's a reasonable rate. So that's my swap's fixed rate, 5.31%. Okay, so we're going to now need to value our swap, and we're asked to value our swap in this question on day 135. Now, on day 135, of course, we've got payments remaining at day in 45 days time, in 225 days time, in 405 days time, and 585 days time. So I'm going to do this on a blank piece of paper because I'll never fit it all in otherwise. Let's get rid of that. There we go. So let us have a nice straight line. There we go. Here's my timeline. Here's my valuation date. First cash flow in 45 days time. Second cash flow in 225 days time. Third cash flow in 405 days time. And the final cash flow in 585 days time. Now, I guess our next thing as well to do is to work out our coupon on our fixed coupon bond. Remember, the swap's fixed rate was 5.31%. Notional principal we had, I can't remember the notional principal. Let's just quickly go back. Notional principal, there it was, 50 million. Notional principal was 50 million on this. Okay, so what we need to do is remember it's semi-annual, so we need to take our swap fixed rate, 5.31%, divide it by 2, and then multiply by the notional principal of a whopping 50 million. So 0.0531 divided by 2 times 50 million. And I get 1,327,500. So on our fixed coupon side, fixed coupon bond side, 1,327,500, 1,327,500, 1,327,500, and finally 1,327,500. Okay, what we now need to do is discount these back to our valuation date. And to do that, very important that you get the right table to use here. So we need, here you go, here's 135 days later. We're going to use the rates in Exhibit 2, okay? So we're going to multiply by 0.9942. This rate's going to come back at 0.9689. This is coming back at 0.9370. And the final amount, oh, I forgot my notional principal as well. Let's stick the 50 million in there. Get my par value back at the end of the bond's life. So the final amount's coming back at 0.90, sorry, 90, it's a bit clearer, 0.9093. Okay, so a lot of manual computations here. There is a shortcut, which I'll show you in a second. So 1,32750. 1,327,500. There we go. Times 0.9942. I get 1,319,800.5. And again, of course, in the exam, I wouldn't be writing it all down like this. I'll be using the memory functions on my calculator. So next one, 1,327,500 times 0.9689. 1,286,214.75. And again, times 0.9370. 1,243,867.5. And then the final lot, 51,000,000 327,500 times 0.9093, and that gives us a value of 46,672,095.75. Add those all up, and you got the value of the fixed side. So 1319800.5 plus 1286214.75 plus 1243867.5 plus 46,672.095 Add that all together and you get 50,521,979. I'm going to round to the nearest dollar. Now, I just said it was a quick way of arriving at that, and there really is. That is a lot of discounting coupons. But a coupon on a bond, of course, is an annuity payment. So a quicker way of doing the same sum and coming to the same value is to take your 1,327,500 and multiply it by an annuity factor. Now, the annuity factor is simply the sum of the discount rates. So 0.9942 plus 0.9689 plus 0.9370 plus 0.909093. So that gives me an annuity factor of 3.8094. And that will discount all of your coupons back simultaneously. So times 1327500. That tells me present value of all of the coupons is 5,056,978.50. Now, the only other thing I've got is the principal at T85, so I need to discount that back. So that's 50 million. And we're going to discount that back. It's not an annuity, so we're just going to use the normal discount factor. So 50 million times 0.9093, that gives us 45,465,000 overall. Add the two amounts together. And you get 50,521,979 with a bit of rounding of one decimal place. So notice they're exactly the same. Okay, so just be aware of that. Using an annuity factor here is a bit of a shortcut. It's just saving you a bit of time in the exam. And that's not set out in the Institute's material or the Swathes of materials, in fact, anywhere. So it's just a little tip, if you like, from me to you, where you can save some time. Right, we know the value of the fixed side. Thank the Lord. Now we've got to do is work out the value of the floating side. Now, the good news is, because the floating side is an equity index, it's really easy. We look at the value of the equity index at the valuation date. Okay, valuation of the equity index at the valuation date. There it is, 6,787. And we compare it at the last settlement date. Well, we haven't had a settlement yet, so therefore we would just take the value of the index when the swap was created. Okay. If you're past the first settlement date, then it's just comparing to the last settlement. So we're going to do 6,786 over 6,258 times my notional principal of 50 million. And that's it for the equity side. Nothing else to it. There's no discounting because you've not got any cash flows in the future. You're looking at the holding period return from the last settlement date to the valuation date. So this is coming out at the valuation date, okay? So no discounting required. 6,786 divided by 6,258. So my 1 plus my holding period return is 1.08437 times my 50 million. Okay, and I get a value here, 54,218,600. Again, I'm not going to bother about decimals in this. Now, this party was receiving the equity return. So they're receiving equity. So again, the value, our value, is equal to what we receive. I'm receiving, no, I'm putting pounds there, sorry. It's, oh, it is in pounds, isn't it? I do know why I'm putting pounds in there. I'm receiving 54,218,600 because I'm receiving the equity returns, less what I'm paying. I'm paying the fixed coupon return, and that was, there it is, 5,521,979. Okay, so 50,521,979. Difference between those, I get a difference of 3 million. It's positive. 3,696,621. Okay, job done. That is the value. It's a gain. So let's have a look and see if that is the answer to our question. Let's have a look at question 1. Using exhibits 1 and 2, the value of the equity swap on day 1 through 5 is closest to, we're closest to, aren't we? We're very close to being at 3.7 million. Because we're 3,960,000. So answer is B for that particular question. Oof, what a lot of work. Now, let's have a look at question 2. Using exhibits 1 and 3, the value of the plain vanilla interest rate swap 180 days after initiation. So exhibit 1, go back to it, there's exhibit 1. That was just the original LIBOR used to calculate the fixed rate. Fabulous. And we're using exhibit 3. Notice the notional principal on this swap is 15 million. Okay. And we're receiving fixed. So they are they're receiving fixed and paying floating. And exhibit 3, there's our LIBOR rates that we're going to use essentially here. Right, now the beauty is, remember, because we're valuing the interest rate swap at a settlement date or immediately after a settlement date, okay, immediately after 180 days have passed, we know the value of the floating rate note. That is always going to be par. So all we're going to do is value the fixed coupon bond. Now you can use the Institute's formula where you compare the old fixed rate to the new fixed rate, etc. And the solution, in the solutions, I have done it that way, but I've also given you the alternative, which is to think about it as bonds. And really, whilst you're getting to grips with swaps, and you're trying to understand the mechanics of what's going on, and everybody finds them hard that's not encountered them before, I really want you to think about them as being fixed coupon bond and floating rate note, especially on the interest rate swap, because things become a lot simpler when you understand that's all you're doing. Right, okay, so let's have a look at this then. So we've already worked out the fixed rate. Remember, we've already worked out the fixed rate. I'll just go and find it. Where was our fixed rate? Oh, maybe we did it in the question, did we? Did I? There it was. Yeah, there's the fixed rate, 5.31. So that's not going to change because we're using the same sterling LIBOR interest rates from Exhibit 1. So again, it's still going to, the fixed side is going to be 5.31%. Right. So here we go. Let's draw out our timeline. Here we are at our valuation date after 180 days have passed. So then the second cash flow is now at T180. Third cash flow is going to be at T360. And the final cash flow on the swap at the end of the second year is now T540. Now, of course, we've got notional principal of 15 million here. So our next thing that we really need to do is to simply work out the coupon. So our coupon here is going to be our 5.31% divided by 2 times the notional principal, which is 15 million. So 5.31 divided by 2. Remember, we're doing that because it's a semi-annual paying swap. So that gives us 0.02655 times our 15 million. And that gives me coupons on my fixed coupon bond of £398,250. So we can do 398,250, 398,250, 398,250, and of course the principal, which is 15 million on the interest rate swap. We're then going to have to discount this cash flow back 180 days, this cash flow back 360 days, and this cash flow back 540 days. And of course, the 180, 360, and 540-day LIBOR are the LIBOR rates at your valuation date. So in other words, if I go back to this, no longer using Exhibit 1, to discount these cash flows, I need to look at UK LIBOR rates at the valuation date. And here they are in Exhibit 3. So my discount factors are 0.9824, 0.9613, and 0.9336. Okay, so again, I'm going to do the shortcut here. I'll put the rates in just so we're happy, times 0.9824 times 0.9613 and times 0.9336. Let me just check those rates are right. Just look at 9336, 9613. Yes, they are. Fabulous. Right, okay, now again, I'm going to be a bit lazy here. Well, I say lazy, I'm going to just do what's sensible. I'm going to add up my discount factors and multiply by the coupon to work out the present value of coupons all in one calculation. So 0.9824 plus 0.9613 plus 0.9336. So my annuity factor is 2.8773 times my cash flow, which is 398,250. The present value of all of those coupons is, in sterling, 1,145,885. Again, I'm going to round to the nearest pound here. Not going to get worried about decimals. Other thing I've got is the notional principal of 15 million, and its discount factor is 0.9336. So 15 million times 0.9336. That's a nice number. 14,004,000. Add them together, and you got the value of your fixed coupon bond. So I get a value of 15,149,885. Okay, now we are good to go because we know the value of the floating rate note, because we're at a settlement date, is equal to par, and par is 15 million. So that side's done. Don't even need to do any computation. Now remember, in this question, they're the fixed rate receiver. Okay, lovely. So we can finish it off now by saying, right, okay, so the value to you, you're going to receive the fixed payments worth 15,149,885. You're going to pay the floating payments, which are rather nice, 15 million, because we're at a settlement date, and therefore the gain to you is the difference, 149,885. So let's return to our question. Have a look at the answers to question 2, and there we go. The answer is B for that one. Did I say I got answer? What did I get? 3,696,000, didn't I, for first question? Yeah. Okay. Cool. Okay. So we got B. Right. Question 3. Using exhibits 2 and 4, the value of the currency swap on day 1 through 5. Now, if I see currency swaps coming up in the exam, I have to say I tend to leave them till last because I know that they're fiddly, I know they're time consuming, and therefore the chances of making some form of screw up is really quite high on these. Okay, let's have a look at the information again because I can't remember what it was. Let's have a look. Here we go. Here's all the stuff on the currency swap. They're bullish on pound versus dollar. They're entering a 2-year currency swap, semi-annual payments, making payments in the dollar. So they're paying the dollar side and receiving the sterling side. Swap is based on 25 million sterling and pays 5.31% fixed on the pound and 5% fixed on the US dollar. The exchange rate at the time of initiation is $1.64 per pound. Now, first thing I would typically do is say, well, okay, at initiation, if we're looking at 25 million pounds, what is that in dollars? And you always take the exchange rate at initiation, multiply it through. So the principal on the dollar fixed bond, okay, the fixed coupon dollar-based bond, 25 million times 1.64, and I get a dollar-based bond worth 41 million. Okay, so all I'm doing there is working out the principal on the dollar-based bond, and it's always use the exchange rate at the time of the swap was created. Okay, always important. Lovely, I've got my fixed rates, so there's 5% on the dollar and 5.31 again on the pound. 135 days have passed. Again, the exchange rate now is $1.72. Now that's going to come in to account when I value this. And notice our question here is, what is the value of the currency swap on day 1 through 5? So I'm going to need to use this for the dollar-based bond. Okay, and of course, I'm going to have to use this for the sterling-based bond. So exhibit 2 for the sterling-based bond, exhibit 4 for the dollar-based bond. Let's go ahead and do this then. Right, so let's get it out. Here we are. Here's our valuation date. And we've got cash flows at T45, the first cash flow, T225, T405, and then finally T585. Let's start off with the sterling-based bond. Okay, its coupon rate 5.31. So fixed rate was 5.31%. Divide that by 2 and multiply by your notional principal. Currency swap, remember, it's based on 25 million sterling. So 0.0531 divide by 2 times 25 million. And that gives me coupons of 663,750, 663,750, 663,750, 663,750, and of course par value of 25 million. Now again, I'm going to take the shortcut, so I'm going to work out my annuity factor rather than writing that all out because I know we're a bit pressed for time. I'm going to go to the sterling interest rates. Where are they? There they are. And I'm just going to add up my discount factors. So 0.9942 plus 0.9689 plus 0.9370 plus 0.9093. And that gives me 3.8094. Okay, so I take my 663 3,750 times 3.8094, which is my annuity factor. Present value of all my coupons is in pounds, 2,528,489. And again, I'm not going to worry about decimals here. Of course, don't forget, you've got your notional principal as well. So 25 million. That's got to come back at the final discount rate of 0.9093. And that gives me a value of 22,732,500. Add them together, and that's the value of your UK bond. Okay, so I get a value of 25,260,989. Okay, that's done. Next thing we need to do is we need to look at our dollar bond. Maybe I'll do it in a different color just so we don't get confused. Okay, so again, timeline, like so. Our valuation date, then we've got T45, T225, T405, and then finally T585. First of all, we've got to work out our coupons. Now remember, US rate was 5%, so 5% divided by 2, and we worked out the par value of the US bond was 41 million. And remember, we got that 41 million using the exchange rate at initiation. So 5% as a decimal, 0.05, divide that by 2 times 41 million. And my coupons, therefore, are $1,025,000 each period. Let's move this up slightly. Dollars after the first one. 1,025,000, 1,025,000. Oh, and don't forget the principal, 41 million US dollars. Now, important thing is, when I discount these cash flows, I need to use the dollar-based LIBOR rates. So back into the question, don't want to use Exhibit 2 here because these cash flows are in US dollars. So here we go. Here are our discount factors that we're going to use here. So again, I'm going to use the shortcut approach by computing an annuity factor. So 0.9937 plus 0.9676 plus 0.9392 plus 0.9095. That gives me an annuity factor of 3.81. So present value of the coupons on our coupon fixed US dollar fixed coupon bond. So 3.81 times 1,025,000 is in dollars 3,905,250. Then, of course, don't forget the principal value. That's got to be discounted back at the final period's discount rate, which is 9.095. So, again, 41 million times 0.9095. Which gives us 37,289,500. Add them up. And I've got a value of 41,194,750. Now, the problem with that is it's in dollars. So I can't compare my sterling-based bond, which is in good old pounds, with this because it's in dollars. So what do I want to do? Well, I want to convert it into pounds. And to do that, I'm going to use the exchange rate at the valuation date. So again, back into my question, let's lift out that exchange rate. There it was. It is always, always, always the exchange rate at the valuation date, because we're saying the US bond is worth $41 million, or 41,194,750 at the valuation date. What is that worth in pounds? So you'd use the exchange rate at the current point in time. Okay, so all I've got to do is divide by 1.72 dollars per pound, and therefore the sterling equivalent of this is 23,950,436. Now, in this particular question, I believe we were receiving pounds and paying dollars. Okay, so the overall value to us, we're receiving pounds. So I'm going to receive 25,260,989. I'm paying dollars. In sterling, that's the equivalent of paying 23,950,436. Difference between them, it's got to be my value. So 25,260,989 minus 23,950,436. And I get a value of about 1,310,553. Okay, that's our gain to the sterling receiver, dollar payer. So we just need to look and see if that is one of our answers. So let's get into the question. So there it is. It's answer C. Last question is to capitalize on prediction of future interest rate direction in the US. Well, it tells us the future interest rate direction here. US interest rates will increase. So we want a product that goes up when interest rates go up. So that could be the long FRA. That would work. That would work. It could be the pay fixed interest rate swap. That would work. But we haven't been given that. We've been given swaptions. Now, a swaption is an option on a swap. Okay, and a payer swaption, if you exercise that, you are paying fixed, receiving floating. Okay, and a receiver swaption, if you exercise that, you are receiving fixed and paying floating. So again, payer and receiver from the fixed payment point of view. Now, if interest rates are rising, you would want to go with a payer swaption because you are paying fixed. And if interest rates are going up, the new fixed rate on a swaption would be increasing all the time. And therefore, the fixed rate that you've locked into would look like a bargain. Remember, you're paying the fixed rate, and paying a lower fixed rate would be a good thing. Okay, so I've got BBCA. And of course, as I said before, you have got your answers here. So B. Should have checked the answers before I did the question, maybe C. And finally, A. There you go. Fantastic, guys. Right, that's the end of what we're covering tonight. Let me just check any chat to see. Euribor 150 days is 2.6, not 2.9. I'm sure I wrote something gibberish at some point with that manner of writing. Other than that, it doesn't appear that you've got many queries. I hope you found this. Useful. I hope you've answered your own queries as well. The long rate is 2.6, not 2.9. Right. I don't know what that relates to, what question you'd have to tell me. But you've got my email address. Let me just give you my email address again. So if you do have any queries on anything we've covered tonight and you want me to have a look at it again, you can enter that email address there and send me a query. I hope you found this useful. It's very, very, very tough stuff. Swaps. Really tough stuff. One of those things I find with swaps that people really batter and batter and batter, and they never understand it and they give up. But if you can get the understanding, and remember, think about it as being about the bonds. It's all about the bonds for the interest rate swap and the currency swap. And if you understand that and it comes up in the exam, you will be miles ahead of most other people. Lovely. Thank you very, very much for listening in, and very good luck in those examinations. Thank you.